this review, we're going to cover some material from test 4. So the first one, we have multiply and simplify. So you're going to FOIL this out or distribute. So x times 4x is 4x squared. X times negative 2 is negative 2x. Negative 1 times 4x is negative 4x. And negative 1 times negative 2 is positive 2. You'll combine your like terms in the middle to get 4x squared minus 6x plus 2, and that's it. Number 2, simplify. First use the distributive property and then combine like terms. So you're just going to distribute the 2x here. So that will give you 10x squared plus 6x. And then you're going to distribute the 7 here. So that'll give you plus 35x plus 21. We have like terms in the middle. So you end up with 10x squared plus 41x plus 21. Number 3, let's see. Oh, this one says factor. So I was about to make a mistake and distribute, but this one says to factor. So notice that they both have this in parentheses in common. So that's your common factor. So you would write that down first, 5x plus 6y. And if you divide that out, you have 8x minus 7 left. So that's factored. Number 4, factor the expression completely. So you can see that they all have an x in common. So I would start by dividing out the x, which is the common factor. And what I would have left is x squared plus 10x plus 16. I would then want to look in the parentheses and see if I could factor that again. So we would have to figure out what multiplies to get 16 and adds to get 10. So 1 and 16, 2 and 8, 4 and 4. 2 plus 8 is 10, so it is factorable. So this will be x plus 8, and x plus 2. So that's the answer to number 4. Notice number 4 is factor, so you stop there. You don't give answers because it just says factor and it's not an equation. On number 5, it's an equation, so you're going to actually solve. So here you can either solve by factoring if it's factorable, or you can solve using the quadratic formula. So I'm going to try to factor first and see if it's factorable. So let's see, we've got 6x squared plus 11x plus 4 equals 0. So I would have to see if I could find something that multiplies to get 24 and adds to get 11. So 1 and 24, 2 and 12, 3 and 8. It looks like that's going to be what works. So this is going to be 6x squared. Break the 11 up into 3x and 8x from the chart. Bring down the 4 equals 0. And now we're going to do factor by grouping. So the first pair, 3x is in common, so we would write that down. And then we would have 2x plus 1 left. Bring down the plus. In the second pair, 4 is in common, so we would be factoring out a 4. And we would get 2x plus 1 again. Notice that what's in parentheses matches. That should always be the case if you're factor by grouping. Okay, so now we have 2x plus 1 times 3x plus 4 equals 0. So we're going to set each of those equal to 0 and solve. So we'll subtract 1. We get 2x equals negative 1. Divide by 2. So x equals negative 1/2 is one answer. So let's see, negative 1/2. And then the other answer, we would subtract 4 and then divide by 3. So the other answer would be negative 4/3. All right, number 6, write your answers as a list of integers. Oh, that's for number 5 above. We did that. All right, number 6, graph the function, list the vertex. Okay, so we're going to first find the vertex in order to graph it. So remember the x value of the vertex is negative b over 2a. So a is negative 1/5, b is 2, and c is 1. So this will be negative 2 over 2 times a. So this is going to be negative 2 over negative 2/5. This fraction can be seen as a division. So this is the same as negative 2 over 1 times negative 5/2. Because when you divide, you flip the second fraction, change to multiplication. So this will be 10/2, which is 5. So the x value is 5. To find the y value, we plug that in. So we have negative 1/5 times 5 squared plus 2 times 5 plus 1. So that's going to be 25 divided by 5 is 5. So negative 5 plus 10 plus 1. So that will be 6. So our vertex is 5, 6. Oops, 5, 6. Since we have a negative out front, remember that means it's going to be facing down. So our parabola is going to be going down. And we want to figure out what another point would be. So you can either use your graphing calculator to find another point, or you can choose a point and plug it in. So since my vertex x was 5, I want to pick an x close to that. So I'm going to pick x equals 4. And I'm going to plug that in and see what I get. Actually, it'd probably be easier if I just used a 0. So let me re-examine that, because that's going to be gross if I use a 4. Let's use a 0. So if I plug in 0, I'm going to have negative 1/5 times 0 squared plus 2 times 0 plus 1. So that's all 0. So 0, 1 is another point. Okay. So let's see, that's 1, 2, 3, 4, 5 units away. So I'm going to go 1, 2, 3, 4, 5 units away on this side. Remember that you have an axis of symmetry. So once you find one point on one side of the line, you can mirror that on the other side. So that should be our graph of our parabola. All right, number 7, list the solutions to the quadratic function below. Separate your solution values with a comma. Okay, so I'm guessing they want us to set this equal to 0. This was not written very well. So we want to set it equal to 0 and find the zeros. This one, I'm guessing we're probably going to have to use the quadratic formula. A is 2. B is negative 5, and C is negative 5. So the opposite of B plus or minus the square root of B squared minus 4AC all over 2 times A. So we have 5, the two negatives make a positive, square root 25 plus, that'll be 40 all over 4. And then that will be 5 plus or minus the square root of 65 over 4. And then we need to see if 65 can break down. So let me get my calculator. 65 divided by 5 is 13. Those are both prime. There's no pairs, so I can't go any further. So this is my solution to that problem. All right, next we have number 8, simplify the expression completely. So we're just dividing here. So 36 divided by 4 is 9. Since 36 is on top and it's larger, the 9 is going to go on top. Z's, notice that we have more z's on the bottom. We have 3 z cubed on top. That means z times z times z. And on the bottom we have z to the 13th. So there are more z's on the bottom. So z is going to remain on the bottom. And then you subtract. So 13 minus 3 is 10. So 9 over z to the 10th is the answer for that one. Number 9, simplify. So we want to simplify each part first. So the x cubed squared, that will be x to the 6th. And then y to the 5th to the 4th will be y to the 20th. So that's where you multiply the exponents together. Since those are different variables, that's as much as we could do right there. Number 10, multiply and simplify. So we're just going to look at 2 at a time. So I'm going to do these first. So I'm going to distribute the 6 to both items there. I do not distribute the 6 all the way across. I only do 2 things at a time. So 6 times 3b is 18b. And then 6 times 4 is 24. And then I multiply that by the b minus 2. So 18b times b is 18b squared. 18b times negative 2 is negative 36b. 24 times b is 24b. 24 times negative 2 is negative 48. These are like terms. So we get 18b squared. 36 minus 24 is negative 12b minus 48. All right, number 11, factor the following expression completely. So since we have 4 terms, I'm going to assume that we can probably do factor by grouping. So that's a good guess if you have 4 terms. So you're looking for the common factor of the first pair and the common factor of the second pair. So the first pair has z squared in common. So I'm going to write that down outside and see what's left when I divide that out. I will have z minus 2. The second pair, I've got a plus in the middle. They have a 10 in common. So I'm going to be dividing out a 10. And I will get z minus 2 as well. So notice what's in black is the same. The parentheses is the same. So z minus 2 is one factor. And when I divide that out, I have z squared plus 10 left as my other factor. That's factored completely because z squared plus 10 cannot factor any further. So I'm done. Now keep in mind, so this is done if I would have gotten something like, let me just use completely different variables so that you know I'm making this up. If I had gotten this and then x squared minus 4, this could factor again because it's a difference of squares. So you would have to take this one further, and this would be x plus 2, x minus 2. So don't forget to see if you can factor it more. The one that we just did, the z squared plus 10, is done because it's a plus, first of all, and second of all, because 10 is not a perfect square. So just keep your eye out for that. All right, number 12, factor completely. So we're not solving, we're just factoring. So we have 5t squared plus 13t plus 6. So we need the product to be 30, 5 times 6, and we need the sum to be the middle number, which is 13. So I can go through and make my list. And I will see that the ones that add together to give me 13 are 3 and 10. So this will be 5t squared plus 3t. Remember, you bring your first one down, you split the middle into the 2 numbers you find in the chart, so 3t and 10t. Bring down the last, and then you do factor by grouping. So t is in common with the first pair. That would be 5t plus 3. We bring down the plus. It looks like maybe a 2 is in common with the second pair, and that would leave 5t plus 3. So 5t plus 3 times t plus 2 is the factored version of that one. All right, number 13, solve the equation. I'm going to go back up. I'm going to need some room for scratch work here. So at first it looks like it would be good that the left side is factored, but since it's not set equal to 0, that's actually not helpful. So I'm going to have to distribute first. So I'm going to get m squared minus 19m is equal to negative 88. And then I want to move that to the other side of the equal sign. So I'm going to add it to both sides. So m squared minus 19m plus 88 is equal to 0. It looks like this might factor. So I want the product to be an 88, and I want the sum to be negative 19. So I can go through my whole list if I want, but the one I was thinking of is 8 and 11. So let's see. 8 and 11. They both have to be the same sign because they have to make a positive 88, but I need them to add to a negative 19. So if I make them both negative, a negative 8 plus a negative 11 is a negative 19. So that works. So it's going to be m minus, not 9, m minus 8 and m minus 11, because negative 8 times negative 11 is positive 88. And negative 8 plus negative 11 is negative 19. And then I'm solving this one, so I'm going to set each equation equal to 0 and solve. Add 8 to both sides, we'll get 8. Add 11 to both sides, we get 11. So the answers are 8 and 11. All right, 14. The revenue generated from an 80-unit apartment building can be modeled with a polynomial given by R, where X is the number of apartments rented at one time. The monthly cost to maintain the apartments is given by the equation C. Again, X is equal to the number of apartments rented. Find the profit polynomial that describes the total profit generated by the apartment complex based on the number of apartments rented. So to find the profit, you're going to take the revenue, what you made, and subtract the cost, which is what it cost you to maintain the apartments. So it's going to be revenue minus cost. So the revenue is given by negative 28x squared plus 370x plus 25,000 minus the cost is 160x plus 1,070. We're going to distribute that negative. So that's going to be negative 28x squared plus 370x plus 25,000 minus 160x minus 1070. And we'll get negative 28x squared plus 210x. Let me just make sure I'm not making a mistake. Okay, and then 25,000 minus 1070 is 23,930. So that is the profit polynomial. So we can say P equals negative 28x squared plus 210x plus 23,930. And the second part is give the profit earned if 57 units are rented. So remember that it tells you X is the number of apartments rented. So here they're telling you that's 57. So we would plug that in for X. So negative 28 times 57 squared plus 210 times 57 plus 23,930. And if we plug that in, we should get the answer. Okay, so I'm getting negative 90,972 plus 11,970 plus 23,930. So when we add all this together, 90,972 negative plus 11,970 plus 23,930, we get negative $55,072. So obviously it's a negative, that's not good. So they're losing money. So they need to change, probably increase the number of apartments that they're renting. Okay, number 15. The cost in dollars to produce X vats of ice cream is given by the C function. When selling them to ice cream shops, the price demand function in dollars per vat is given by a little p function. Find the profit function, which is the big P function. So we'll start by multiplying the items in the P of X, little p of X by X. Whoops. So that will give us 58x minus 2x squared. And then we want to take that, that gives us the revenue, and we're going to subtract the cost. So that's going to give us negative 2x squared, I'm going to reorder it, plus 58x minus 2x minus 9. So that's going to give us negative 2x squared plus 56x minus 9. So that's the profit function. So negative 2x squared plus 56x minus 9. Now they want to know how many vats of ice cream need to be sold to maximize the profit. Okay. So we want to maximize that. Remember, maximize means we're finding the vertex. I'm just going to erase that. So to find the vertex, you do negative b over 2a. So that's going to be negative 56 over 2 times negative 2. So let's see, calculator, 56 divided by 4 is 14. Okay, so that is your x value of the vertex. So let's go back and refer to what it says in the thing. It says x vats of ice cream. So x stands for vats of ice cream. So it says 14 vats of ice cream. So how many vats of ice cream need to be sold? 14 vats of ice cream. So you would choose option C, and you would put a 14 there. Okay, and then the next one, find the maximum profit. So we would take 14 and plug it in. So our profit function is going to be maximized if we sell 14. So we're going to plug in 14 for X. And let's see what we get. So we have 14 squared times negative 2 is negative 392. 56 times 14 is 784 minus 9. So 784, a negative 392, and a negative 9 gives us 383. So that's the profit that they would make. So you would choose part B, and you would say $383. And I think there might be one more. Yep, number 16. Simplify the square root of 63. So when you're doing that, you make a factor tree. So 63 I could break down into 9 times 7. 9 I could break down into 3 times 3. 7 is prime, 3 is prime. So I'm looking for pairs. So I have a pair of 3s, that would come out. 7 is by itself, that would stay under. So it would be a 3 square root 7.